Hello everyone, welcome back to our pre-calculus pre-recording video. This is about matrix algebra and we have introduction to matrix algebra, addition, subtraction and multiplication. These three things we'll try to understand in detail in this lesson. So these are the agenda: find the sum and difference of two matrices, find the scalar multiple of matrix and the find a multiple of two matrices. Then we have some like practice homework or in-class practice, this and that. So let's look at what is matrix thing. What is that thing? Matrix, the definition of matrix is very simple actually. The definition of matrix is it is just a table of numbers. Just a table of numbers. So you can say that very simply, if we just write some number like 1, 2, 3, 4, basically this is a matrix. Just a representation or table of numbers. Okay. It has and it contains some special properties which we will discuss, of course, uh, like for its addition, subtraction, multiplication, for this thing. So it has some special characteristics that which is coming up, but in general this is just a representation of numbers in some rectangular array. That's why it is said that a matrix is defined as a rectangular array of numbers like this. And notice that when you have some, this is the column 1, column 2, column 3, this is column, let's say column n or something like that, and these are the row, this is column, these are rows. Okay, like this way when you go, these are rows, and this way when you come, these are columns. Okay, this is row, columns, and this is row. We'll say a lot of time about them. Okay, that's why you need to look at them very carefully. This is row 2. Suppose this is row 1, then this is row 2. In this case, this is row I because it is I written here. But if there is dot dot dot, that's why we say row I. Then row M. So first value is for the row. Okay, this is 1, 2, I, M. So that first value is for row. Then second value is for the column. Okay, this is column 1, this is column 2, this is column 3. So column 1, column 2. See, this is small number here is 2. Column 1, column 2. So if something is A2, 3, A2, 3, what does it mean? So first number is what? First number is row. So that means row 2, and column is what? Column is 3. Column is 3. So that means, let's say if I write here 1, 2, 3, 4, 5, 6, and then if I say something like go to some number, let's say A is a number here which is in let's say 2, 1. What does it mean? That means it says that row 2 and it says column 1. Column 1. So row 1 is this one. This is row 1. This is row 2. And this is column 1. This is column 2. This is column 3. So row 2 column 1 is 4. So this number equal to 4. Okay. And let's say if I say row 2 column 3, so that number will be what? That number will be 6. That number will be 6. So this is how we find out which one is row, which one is column. And always this notation will work, like if it is A, M, N, this M is the row, this N is the column. Okay, this M is the row, and the first one is row, first one is row, first one is row, first one is row. Always you can keep it in mind this way. Tell it a couple of times so that you go there. Now this is about the addition of matrices. So this is actually simple. Addition is simple. Let's say if you have 2 3 5 6 and another matrix we want to add. Let's say we have something like 5 5 3 1 2. If we want to add it, this is simple. Just add the first number. So 2 plus 5 means 7, then this 3, then 3 3 6, then 5 and 1 is 6, then 6 and 2 is 8. We are adding their respective numbers. Okay, this is first position, this is also first position, this is second position, or you can say row 1 column 2, this is also row 1 column 2, so add them together. Okay, this is row 2 column 1, so this one is also row 2 column 1, so add them together. Okay, so this is the addition thing. Addition thing is just simple. Suppose this is row 1 column 2, so this is also row 1 column 2, we will have to add them together. So 4 plus 4, and we will have to put it here. That will be 8, of course. And for the subtraction, what we do is we just do the opposite thing of what we have done here, basically. So for subtraction, we just have to write here the negative sign. Let's say the same math let's say the same math we want to do. Just in this case, we want to do the subtraction. How do we do that? So this is 2 then minus 5. Okay, 2 then minus 5. 2 minus 5. We can write it here, or we can write the answer both. So 2 minus 5 means minus 3 actually. Okay, minus 3. 2 minus 5. See, 2 minus 5 equal to minus 3. Then 3 minus 3. 3 minus 3 equal to 0. Do you understand? Then 5 minus 1. 5 minus 1 equal to 4. 6 minus 2. 6 minus 2 equal to 4. This is the answer, subtraction. Okay, this is the subtraction. We just subtract their respective term from one another. That's it. Then it says that matrix addition is commutative. That means a plus b equals to b plus a. It means very simple, like something like we can show it with many numbers, but if you just look at a small, very simple example, let's say 2 plus 3 and 3 plus 2 plus 3 equal to 6. Also 3 plus 2 equal to also 6. So if you interchange them, it doesn't matter. A plus b and b plus a is same thing basically. Same thing. You can write it in terms of matrix also, they will give you the same answer. Matrix addition is also associative. Okay, that means if you write some matrix here, some matrix here, and some matrix here, if you add these two first and then later add with C, you will get some answer, and you will get the same answer if you add B and C first, then A. So matrix, this is called the associative property. This is called the commutative. Commutative means they will interchange. You know, in place of A it will be B, in place of B it will be A. But this is not true for a subtraction, because as you know, in the subtraction we can actually explain it a very simple simple rule. Although we said about multiplication actually. We said about 6. So 2 plus 3 is 5, and then 3 plus 2 is also 5. What's going on? Okay, then so basically you get the same thing, 2 plus 3 and 3 plus 2. So if the interchange doesn't matter, this is what it says, that commutative. But this matters when it is subtraction. Suppose if I write 2 minus 3, this equals to what? This equals to minus 1. And if I write 3 minus 2, this equals to what? This equals to plus 1. Okay, so that's why we said that this is not true for subtraction. Okay, true for addition. In addition, you can just interchange them, but not for the subtraction, because then answer changes. Scalar multiple of the matrix. This is a lot of maths, as you can see here, but this is not super scary anything. Basically, suppose you have something like this one, 9 0 minus 3 6. So how do you do? How do you multiply? Let's say if I say that this is a matrix C, so find out. Let's say 3C equal to what, or 4C, or 2C equal to what. Let's say 2C equal to what. That means you multiply it by 2. When you multiply, all of them will be multiplied by the 2. So 2 into 9 means 18, 0 into 2 means 0, minus 3 into 2 means minus 6, 6 into 2 means 12. So we have this. Okay. Then if we have like this math 1/3 of this, so basically then you will have to multiply by 1/3. Okay. And that's also simple. Like 1/3 of C means 9 0 minus 3 6. Then you just multiply it by 1/3. So you have, let's write them nicely. 9 0 minus 3 6. So if we multiply it by 1/3, then it becomes let's write it here together, so that it is good for cancellation. Then we just do some cancellation, and we will get the answer here. This and this cancel out, so you get 3. This is 0, so basically it will become 0. Then this and this cancel out, you get a minus, so minus 1. This and this cancel out, you get 2 here, so 2. That means this way we do it. Scalar multiple means multiplying by some number. So if you multiply by some number, then basically all the entire matrix will get that number, you know. So this is what is going on here. Find the product of two matrices. So we are starting something. A row vector R is called just a row. A matrix which have only the element in the row. Okay, there is like only one row. Okay, only one row. Like this other things is not given, only one row. That's why it is called row vector or row matrix. Okay, and column vector is just only one column. Just only one column. Suppose if I write, like, so to give you an example, suppose if I write something like 2 3 5, just only this, nothing else. So this is suppose if I say A equal to this, then we will say that this is a row vector or row matrix. That's simply it. And if I just write only something like B equal to, let's say, just some column element 1, let's say 1 to 3, or 1 to 0, suppose 1 to 0. So just only one column. We have nothing else. Like there is no other column. Just only one column. One column and 3 row, of course, as you can see, 3 row here. So this is the column vector or column matrix. Now, if we want to multiply, how it works? Multiplication. Now we are entering into the multiplication. If I want to do A into B, what will happen is you will have to multiply this and this. So basically, it will be like 2 into 1, then plus 3 into 2, 3 into 2, then plus 5 into 0, 5 into 0. Then ultimately what will happen here is 2 into 1 means 2, 3, okay, 2 plus 6 plus 0. So ultimately what will happen is just only 8. So if I multiply this and this, we just get 8 here. What we have done is we have multiplied with the corresponding terms. Okay, this is the first one, so multiplied with the first one. This is the second one, multiplied with the second one. Third one, kind of that. And how it goes, see, it goes this direction and it comes down here. Okay, you can say, sir, why? Why it is happening this way? Why it is happening this way? The reason is this is some convention that people agreed upon. Basically, you know, this is if they started it differently, then things would have been different. Okay, So, but this helps. The entire process helps in many ways in the process. So here we have more multiplication. Let me show you one. A, B, B, A. Which one is hard? Both is easy. It looks hard because there is many things here. So let's do BA. So 1, 0, 2, 1, 3, 2. BA, notice BA means you will have to write B first, then A. Okay? 2, 1, 3, 1 minus 1, 0. Okay? So this equals to what? This equals to, first, we said that this into this, that means 2 into 1 means 2. Then this into this, okay, then plus 0 into 1, that means 0. So we will not have to write anything else. So what we have done here, first one, then this is second one, then second one. So first it goes through this direction, then it comes down like this. Let's make a box so that it is clearly visible. So you go this way, then you come down this way, okay, this way it goes, and second time it will come down this way for this one. This is same color, let's use another color. So this will come down like this now, okay, since we are starting the step 2. So let's go. So 1 into 1, that means 1, then 0 into minus 1, that means 0. So basically plus 0. Okay, we are still multiplying with the first one. This first line not yet finished. Then we will have to, we need a box, right? I thought that I have taken a box. So we take this, then we multiply it with this. So 1 into 3 means 3. So 1 into 3 means 3. 1 into 3 means 3. Then 0 means 0. So we have done. We are done with the first row. First row and multiply with all of them. So we are done. That's why all the terms here is in the row. Now we will start doing with the second row. Okay, second row. Same thing, second row. So this into this, then again this into this, then again this into this. Okay. So if we multiply, how it happens? Let's use some other color. I think all are good. Let's use red for all of them. So 2 into 2, that means 4. Then 1 into 1, that means 1. That means 2 into 2, that means 2. Then 1 into minus 1, that means minus 1. Then again 2 into 3 means 6. Then 1 into 0 means 0. Then 3 into 2 means 6. 2 into 2 means 2. 2 into 1 means 2. Then 3 into 1 means 3. 2 into minus 1 means minus 2. 3 into 3 means 6. 2 into 0 means 0. So what we have here ultimately? Ultimately what we have here is, let's write it here. Ultimately what we have here is 2, 1, 3, then 4, 2 minus 1 equals to 1, 6, this is 8, 3 minus 2 is 1, then 6. This will be 9, right? Because 3 into 3 means 9. So this will be 9, 6, 3, 1, 1, 1. Oh, this is 5. What is going on? This is 5 here. This is 5 here because 4 plus 1 equal to 4 plus 1 equal to 5. Okay. So this is like multiplication. So for multiplication, what we do is we just go along the row and then come down along the column, and then just do the addition. And of course, we will have to be careful always for this kind of situation, because one mistake and then the entire thing is like not correct anymore. Yeah. So yeah, and this is how it works. Like let's now look at the theory of this multiplication. This is important. So if you have two matrices, suppose a matrix A and matrix B, How do we know that if we can multiply it or not? How do we know that? This is what? How many row we have and how many column we have. How many row we have, how many column we have. So we have 2 row and 3 columns. So it is 2 by 3 matrix. Okay, 2 row and 3 columns. So it is 2 by 3 matrix. This is how much? 1, 2, 3. So this is how many rows? 3 rows. So it is 3 by how many column? 1, 2, 3, 4. 4 column. So 3 by 4 matrix. That means the theory says that if a matrix is m by r and r by n, this number has to be same. Then we can do the multiplication. That means this number, this is 3 and this is 3. As they are same, so you can do this multiplication. Let me tell you what I mean by this. So let's say 2, 1, 1, 3. Let's say I write here 1, 2, 3. Then 4, 5, 6. Just to show you what's going on. If I want to multiply it, can I multiply it? See, I can multiply it 2 and 1, then 1 and 5, 1 and 2. Then there is nothing here to multiply with the 3. That means this multiplication is not possible. Okay, this multiplication is not possible. So how it is possible? What is the rule? The rule is if some matrix is given something by something and something by something, the second number of the first matrix must match with the first number with the second matrix. In other words, you can see just by looking at the theory, m by r, r by n. That means this r and r should match. Then we can do the multiplication. Okay, so this 3 and 3 matching, that means we can do the multiplication. It doesn't matter what is this number, Of course, it should not be like 0, then it is like pointless what is going on here. Okay, so this first number and second number doesn't matter. It is okay. All right, and the answer will be this. So this number actually has some significance. This second 2 also has some significance. Their significance is the answer will be 2 by 4 matrix. Okay, the answer will be 2 by 4 matrix. If we multiply these 2, then answer will be this 2 by 4 matrix. Okay, so this is what we know about the about this matrix thing. When we multiply it, how can we multiply it? What is the condition? The condition is this thing and this thing has to be same, or else you cannot multiply. Okay, because there will be something missing. We will not be able to multiply it. And matrix multiplication follows the associative and distributive rule, but it is not commutative. Commutative means if you multiply AB, it is not equal to multiplying with by BA. The answer changes. Some answer changes because it goes this way and then comes this way. So basically, the pattern is different now. So it is not commutative. That is what it says. We can prove it in the class. Just feel free to ask me if you need for detailed explanation of all this and that. Okay, don't worry. We can do them. Okay, no problem. So we have, this is called the identity matrix. Identity matrix is like when you have some matrix where you have just the diagonal element is 1 and all other values are 0. This is called the identity matrix. The diagonal element is 1, everything else is 0. Okay, this is called the identity matrix. Diagonal element is 1 and everything else is 0. Why it is important here? Because the rule is if you multiply a matrix with a diagonal matrix, then the answer is always the same. Same thing. Like if you start with A, then you multiply with a diagonal matrix. Suppose in this case I3. I3 means 3 into 3. I2 means 2 into 2 diagonal. Then you will get the same thing. You can say that, whoa, then why we are studying it? This is crazy. You will see. We will extend our idea later. You will see that where it takes. For example, when we will start discussing the inverse matrix, then you will see that this in identity matrix is playing interesting role there. So A into I3 will give you the just only A, just the same thing. I2 into A will give you just A. B into I2 will give. That means if you multiply with the identity matrix, a matrix, if you multiply with the identity matrix, you get the same result. You get the same result. That is the thing. Of course, the order has to be same so that you can do the multiplication. I think you know it now. So what is this identity matrix is doing basically? It is basically something like 1, 1. If you multiply 6 into 1, the answer remains 6. If you multiply 7 into 1, the answer remains 7. If you multiply 1 into 7, answer remains 7. So basically, in our the real number 1 and identity matrix in the matrix algebra is same thing. Do you understand? The real number 1 in our algebra, like you have done this, like 1 into 7, 7. So this real number 1, what it does in the algebra, in the matrix algebra, identity matrix does the same thing. If you multiply with the identity matrix, answer remains the same. Okay. So yeah, it's written here also. We will try to solve this kind of maths during our class time as an in-class practice. So that's the plan, and that's all for today. Thank you all. Thank you very much. Have a good day. Also, notice that this is 11.4, but we will go back and forth to discuss other contents. Don't worry. So have a good day and see you all in the class. Bye-bye.